We're all familiar with these amazing places: the Grand Canyon, Niagara Falls, Victoria Falls, the Great Barrier Reef, the Northern Lights, Mount Fuji. These are some of the most spectacular sights our planet has to offer. But they're not unique. There are plenty more just like them all around us. For example, you may have seen this one before. It's what happens when water cascades over a cliff edge into a pool below. And if you search online for waterfall, you'll see that it's basically the same image over and over again. They look different because the height of the cliffs and the depth of the pools vary, but the underlying physics is always the same. In fact, every waterfall on Earth behaves exactly the same way. That's because gravity works the same way everywhere on Earth, and the physics that describes how waterfalls work can be found in Newton's law of universal gravitation. This is the equation that determines how the force of gravity between two objects depends on their masses, and the distance between them. According to this equation, the force of gravity between two objects is inversely proportional to the square of the distance between them. What does this mean? Well, let's take this waterfall, for example. At the top of the waterfall, the water has gravitational potential energy because of its height. As it falls, this potential energy is converted into kinetic energy, which is why you hear the water making a lot of noise as it hits the pool below. The key thing to note here is that the water is falling a long way. If we were to measure the distance between the top of the waterfall and the pool below, we would find that it is very large compared to the size of the water. However, as the water falls, the distance between the water and the pool gets smaller and smaller. So according to Newton's law of universal gravitation, the force of gravity between the water and the pool gets stronger and stronger as the water gets closer and closer to the pool. This means that as the water approaches the pool, the gravitational force between the water and the pool does work on the water, and this work done by the gravitational force results in an increase in the speed of the water, which is why the water at the bottom of the waterfall is moving so fast. But there's another interesting thing going on here. As the water approaches the pool, the surface of the pool gets closer and closer to the level of the water, reducing the vertical distance between them. And this means that the force of gravity between the water and the pool is getting weaker and weaker, which means that the work done by the gravitational force on the water is getting less and less. And since the water is no longer being slowed down by the gravitational force, it doesn't build up any pressure at the bottom of the waterfall, even though it's moving really fast. In fact, we can use this principle to design a perfectly safe water slide. If we make the slide very smooth, then the water will slide down the slide without building up any pressure. But what happens when the water hits the pool? You may think that the water should come to a stop as soon as it hits the pool, but this isn't the case. Instead, the water continues to move forward after hitting the pool. To understand why this happens, we need to consider what happens to the water once it's hit the pool. The water is pushed out of the way, which means that the volume of the water in the pool increases. Now, if the volume of the water in the pool increases, then the surface of the water must also rise. And this means that the force of gravity between the water and the pool is now greater than before. Since the force of gravity between the water and the pool is greater than before, the water is now being pulled back upwards towards the top of the waterfall. And this upward motion means that the water at the bottom of the waterfall is no longer moving forward. Instead, it's moving upwards. Now, if we repeat this process, we'll find that the water will continue to oscillate up and down until the energy in the system is dissipated by things such as viscosity, and this oscillation is known as a hydraulic jump. Hydraulic jumps can be used to generate electricity. This is how, if we place a turbine in the path of the hydraulic jump, the water will spin the blades of the turbine, which will turn a generator, which will produce electricity. Now, if you want to learn more about how hydraulic jumps work, I recommend checking out this video afterwards. So that was a quick summary of the physics of waterfalls. But did you notice something strange in that video? You probably saw that the water wasn't flowing smoothly. Instead, it was broken up into small droplets. But why? Well, this happens due to something called surface tension. Surface tension is the tendency of liquid surfaces to shrink into the shape that has the smallest surface area. Water molecules at the surface of a liquid are not pulled equally from all directions. This means that there is a net inward pull on the surface molecules, which creates a sort of elastic-like film at the surface of the liquid. This inward pull is what causes surface tension. Now, surface tension is usually a good thing for water, as it allows water to form droplets and therefore reduces the amount of water that evaporates. But surface tension can cause problems in pipes. For example, when water flows through a narrow pipe, the surface tension of the water can cause the water to stick to the walls of the pipe, which can reduce the flow rate of the water. You can actually see this effect for yourself if you pour water into a tall, thin glass. You'll notice that the water forms a sort of dome shape at the top of the glass. This happens because the surface tension of the water is pulling the water molecules at the surface inwards. It can even cause water to defy gravity. Take this glass, for example. You may think that the water will simply fall out of the glass when it reaches the point where it's higher than the center of mass, but this isn't the case. Instead, the surface tension of the water holds the water in place until the weight of the water eventually pulls it down. There are other situations where surface tension can cause problems, like in spray nozzles. For example, If the surface tension of the water is too high, then the water will form a solid plug in the nozzle and the water won't be able to flow through. In these situations, we need to reduce the surface tension of the water. The easiest way to reduce the surface tension of a liquid is to add soap to it. Soap molecules have both a hydrophilic or water-attracting head and a hydrophobic or water-repelling tail. When soap is added to water, the soap molecules form micelles with their hydrophobic tails pointing inwards and their hydrophilic heads pointing outwards. Now micelles are tiny spherical structures that are much smaller than the wavelength of visible light. This means that when light hits a micelle, it gets scattered in all directions. And this scattering of light is what gives soap bubbles their iridescent colors. The important thing to note here is that micelles have no surface tension, because the hydrophobic tails of the soap molecules are hidden from the surrounding water molecules. This means that water solutions containing micelles will have a much lower surface tension than pure water. But wait a minute. We said that the reason why the water wasn't flowing smoothly was because of surface tension. And now we're saying that we can remove surface tension by adding soap. So does this mean that soap makes waterfalls flow more smoothly? Yes, it does. Soap can be used to treat waterfalls in order to reduce surface tension and improve the appearance of the waterfall. However, there are some drawbacks to using soap. For example, soap can damage sensitive aquatic life, and it can also change the chemical composition of the water, which can affect the taste of the water. Therefore, we shouldn't be using soap to treat waterfalls. But there is an alternative. Instead of using soap, we can use a device known as a deflector plate. A deflector plate is simply a flat plate placed in front of the waterfall. The purpose of the deflector plate is to break up the water into smaller droplets, which reduces the surface tension of the water and therefore improves the appearance of the waterfall. Deflector plates are often made from stainless steel or titanium, which are corrosion resistant. One advantage of using a deflector plate over soap is that it doesn't change the chemical composition of the water, and this is important because many waterfalls are used as a source of drinking water. Another advantage of using a deflector plate is that it can also be used to increase the height of a waterfall. This is because the deflector plate acts as a barrier, which prevents the water from spilling over the edge of the waterfall. By increasing the height of a waterfall, we can increase the gravitational potential energy of the water, which can then be converted into kinetic energy. And this means that we can use a waterfall to generate electricity. But wait a second, we said that water slides with zero friction exist. So wouldn't it be possible to design a water slide that would allow water to cascade over a cliff edge without any splashing? Actually, yes, it would. If we could somehow manage to get water to cascade down a cliff face with zero velocity, then the water wouldn't make a lot of noise as it hit the pool below, and there wouldn't be much splashing either. This is because the work done by the gravitational force between the water and the pool would be equal to the change in gravitational potential energy of the water. This means that the water would come to rest at the bottom of the waterfall without any excess kinetic energy, which would result in no splashing. Unfortunately, it's impossible to construct a water slide that would allow water to cascade down a cliff face with zero velocity. However, we can come pretty close. For example, this waterfall comes pretty close to having zero splashing. This is because the water is already moving quite slowly when it reaches the bottom of the waterfall. And even if the water does have some kinetic energy left over, the water is spread out over a large area, which means that the kinetic energy is spread out as well. If we were able to control the shape of the water as it cascaded down the cliff face, we could further reduce the amount of splashing. For example, if we could somehow manage to make the water into a thin sheet, then the kinetic energy of the water would be spread out over a larger area, which would result in less splashing. In conclusion, waterfalls are truly amazing natural phenomena that can be explained by Newton's law of universal gravitation. But did you notice something strange in that video? The water wasn't flowing smoothly. Instead, it was broken up into small droplets due to the surface tension of the water. Surface tension can cause problems in pipes, and it can even cause water to defy gravity. But fortunately, we can reduce the surface tension of water by adding soap or by using a deflector plate. One advantage of using a deflector plate is that it doesn't change the chemical composition of the water. And this is important because many waterfalls are used as a source of drinking water. Another advantage of using a deflector plate is that it can also be used to increase the height of a waterfall, which means that we can increase the gravitational potential energy of the water, and therefore, the power output of the waterfall. If we could somehow manage to get water to cascade down a cliff face with zero velocity, then the water wouldn't make a lot of noise as it hit the pool below, and there wouldn't be much splashing either. Unfortunately, it's impossible to construct a water slide that would allow water to cascade down a cliff face with zero velocity. However, we can come pretty close. For example, this waterfall comes pretty close to having zero splashing. This is because the water is already moving quite slowly when it reaches the bottom of the waterfall. And even if the water does have some kinetic energy left over, the water is spread out over a large area, which means that the kinetic energy is spread out as well. If we were able to control the shape of the water as it cascaded down the cliff face, we could further reduce the amount of splashing. For example, if we could somehow manage to make the water into a thin sheet, then the kinetic energy of the water would be spread out over a larger area, which would result in less splashing. Anyway, hopefully you enjoyed this video. If you did, don't forget to leave a like and subscribe for more content.